Hi everyone, it's Phil from My Math Teacher is Terrible. Thanks for joining. Hope everybody's doing well. Today I feel like I have somewhat of a short topic, but I've only just begun to talk, so I'm not sure how long it's going to go. But it's a little bit about first principles, and it's about algebra. Nothing more complicated than the rules that were taught in something like Algebra 1 or maybe pre-algebra. But that sometimes I feel that students, as they continue in their math studies, sometimes stumble over or have a little bit of trouble understanding or remembering. And, you know, if you're new at it, this will help. If you're not so new at it and could use a little refresher, this may help as well. Just to clarify a few things, as we gain experience in our math classes, sometimes these things, we hope they kind of fall together and click, but sometimes they don't. And I just want to maybe clarify a few things about that and see if it can actually help somebody. So let's give it a try. Okay, so we're just going to talk about the basics of kind of like order of operations and how to isolate a variable, right? If anybody is studying for the SAT, they have this section on there, or they have these sets of problems that have some sort of weird name about like how to isolate a quantity or isolate a variable or whatever. And a lot of times when we're trying to solve a problem using algebra or using other math, we're after some sort of unknown quantity, right? And in the very, very basics, again, pre-algebra and algebra 1, we're talking about using a variable, usually just one variable, and trying to find the value of the variable in a particular situation. And of course, in algebra, we have equations. That's one of the things we deal with. We deal with inequalities as well, and then later on, we do generalize it more to functions and all this kind of stuff. But today, let's just talk about some simple equations, maybe that take one or two steps, or no steps. Let's start with a simple equation. X equals 8. This is an equation. Why is it an equation? Because it has an equal sign. Equations have equal signs, right? Terrible math teachers don't even point this out, but that's all right. I can help. So this is a basic equation, right? And what is the solution? Well, the solution is x equals 8, because what else equals 8 besides 8, right? Done. There you go. Simple equation. But of course, as soon as you master this sort of thing, right, your terrible math teacher like piles some stuff onto it, right? Then we suddenly do stuff like x minus 1 equals 8. Well, it's a little bit more complicated, but sometimes not by much. And again, algebra, basic algebra, is about inverse operations or opposite operations. And basic algebra, algebra 1 and pre-algebra, are about the relationships between adding and subtracting, multiplying and dividing. That's all. I didn't even use all of my fingers, right? That's really what it is. As we progress, of course, it becomes about other things, and there are terrible math teachers in those contexts as well, but also really great ones. But right now, we're just going to be concerned with adding, subtracting, multiplying, and dividing, okay? So in this equation, I'm sure most of you watching can solve this, but let's go through the steps, right? So I'll write the steps in another color because it's fancy, right? We know here that we're going to add 1 to both sides, right, to keep the equality of the equation going, right? And then we just add straight down. That's what's going on. This is x plus 0 is x. Plus 1 minus 1 cancels, really. It turns into 0. And then equals 8 plus 1, 9. And then we can sanity check our answer. Does 9 minus 1 equal 8? Absolutely it does. Fantastic. All right, so that's that kind of thing. What about x plus 2 equals 8? Similar situation, right? The only thing that's different is I'm adding something instead, right? So let's solve this one. Same exact way. What's the opposite of adding? It's subtracting. So I'm going to subtract 2 from both sides. Right? And we see that the 2's will cancel. They turn to 0. And x remains. And 8 minus 2 is 6. And does 6 plus 2 equal 8? Absolutely it does. Fantastic. All right. 2 other kinds. How about 2x equals 8? Right, 2x equals 8. So it's not just this, it's something more complicated. Now I'm multiplying. And the opposite of multiplying is dividing. That's right. So I'm going to do the same thing to both sides. Divide both sides by 2, because that's the thing that's sitting out in front of the x. All right, so here the 2's will cancel, and x equals 8 divided by 2, 4. And is 2 times 4 8? Sure is. One more. How about x divided by 2 equals 8? Running out of room, but let's see how it goes. All right, so now I'm dividing. So the opposite of dividing is multiplying. I'm going to do the same thing to both sides, but I'm going to do the opposite. If I'm dividing by 2, I need to multiply by 2, right, on both sides. And what happens? The 2's cancel, and the x comes down, and then it equals 8 times 2, 16. And we can check our answer. Is 16 divided by 2 8? Absolutely it is. Okay, so we're just establishing that these are the basics of what we do, right? Multiplying, dividing, subtracting, and adding. That's it. Those are the 4 that I held up my fingers for a little earlier. Great. Those I would call the very basics, the square 1 or the square 0 or the underlying base skills or whatever they come up with in your curriculum. Okay. So that's fine. And all of these, they also sometimes call them one-step equations, right? This is a no-step equation. This is a one-step equation because I just did one operation to isolate the variable. After I did one thing, I isolated what x is. I isolated x and showed what it was equal to. Those are one-step equations. And zero-step. This is fine. This helps you learn and also demonstrate on an exam that you can pick out opposite operations and then apply them effectively, which is really what about pre-algebra and algebra 1 is mostly about. But there's an interesting scenario that, again, I feel like some people maybe weren't taught correctly or they aren't quite sure what the heck is going on. Let's talk about this one. Let's talk about this equation. 4x plus 2 equals 8. Right? Okay, so some of my students, pre-algebra, algebra, and sometimes algebra 2, say that I should divide by 4 straight away. But you can divide both sides by 4. But you're going to be dividing everybody by 4. You have to divide this by 4, divide this by 4, and divide this by 4. That is certainly one way to do it. It's complicated. I would not recommend it, and if any followers of my videos hear me discuss from time to time, or of my articles on my website, hear me discuss from time to time that do simpler and cleaner looking operations to minimize the chance that you introduce an error. So suppose I did want to divide by 4, and this is an error, so don't write this down. If I divide by 4 right away, right, what would I do? I'd cross this out, and I'd say x plus 2 equals 2, right, because 8 divided by 4 is 2. And then I subtract 2 from both sides, and I get x equals 0. That's not right. If I put 0 in here, 0 plus 2 is not 8. Right? But I introduced an error because I got to divide everybody by 4. Jeez. Divide by 4. Right? I didn't do that here. I can't do that. I changed what's going on both sides of the equation, right? I didn't do anything with this. I have to. But I introduced an error by trying to divide by 4 first. So we're going to not do that. So let's see. What parts do I have to just rewrite? It's just this part. 4x plus 2 equals 8. And let's make this 10, and you'll see why. So 4x plus 2 equals 10. So I got to get x by itself. I have to get the term involving x by itself. That includes the 4. So really I want to get 4x by itself. Not so bad. right? So in keeping with my other color, I'm going to use blue this time. Okay, so I'm going to subtract 2 from both sides, right? The 2's will cancel, and I'm left with 4x. And then 10 minus 2 is 8. And now we're back to a one-step equation, right? Great. And then we decided earlier, well, I should have written this in black, but I didn't. Divide both sides by 4. The 4's will cancel, and x equals 8 divided by 4 is 2. All right. Now, if I put 2 in here, I get 4 times 2 is 8, plus 2 is 10. Does that equal 10? Of course it does. Absolutely. Great. Now, let's do something a little bit different. I want black and blue. Okay. Let's do something slightly different. Let's do 1/4 x plus 2 equals 10. Now what? First step is exactly the same, right? I got to get this away from this. And I got to get it out of there. Let's do that. Okay, so I'm going to subtract 2 from both sides, same way. All right, these are going to go away, and I'm going to have 1/4 x equals 10 minus 2 is 8. Great. This is the thing that confuses some people. This is correct, absolutely correct. This is the thing that confuses some people, and this is really what I want to talk more about today. Okay, or continue to talk more about. These were not so bad. They seem sort of maybe a little bit more obvious. This is the one. So some people will say, okay, so it's something multiplying x like it was here. So I divide by it. Whatever the heck it is multiplying x, I divide by it. And that's not wrong. But I don't know, half the time maybe, when somebody suggests dividing by 1/4, they're not quite sure how they would do that, like how they would compute it. Right? The easier thing here to do is, well, there's 2 things. One thing that we're taught is to just multiply both sides by 4. And again, I forgot to write this in black. I'll get the hang of this at some point. Right? They say multiply both sides by 4, and then the 4's will cancel, and I get 1x, which is just x, equals 8 times 4, 32. And does that work? If I put 32 in here, well, 32 divided by 4 is 8, and is 8 plus 2 10? Yes, it is. So this is one way to do it, right? If you have a denominator, you multiply by a numerator. And this is division. The 1/4 is division. It's 1 divided by 4. But what's going on between the 1/4 and the x is multiplication. Right? So I didn't do the opposite of multiplying. Like I did the opposite of multiplying here, right? I didn't divide. This is where some folks get confused, and this is what I want to help clarify. So when I have this, or I have 3/4 or something like that, let's try, so if I have 3/4, sometimes it gets way more confusing. Right? This is one way to do it and get the correct answer. Let's look at it again, and let's talk about another way that sometimes people get the right answer, and a good way to do it. Okay, so we said 1/4 x equals 1/4 x in black equals 8. Some students are taught correctly that, and only one way of being correct. We just saw another way of being correct. When you have a fraction that's multiplying here, multiply by the reciprocal of the fraction. Man, reciprocal is a weird word the first 25 times you hear it, right? But reciprocal just means take the fraction and turn it over, like flip it over. So what's on the bottom goes on the top, and what's on the top goes on the bottom. Multiply both sides by the reciprocal of the fraction. In blue, Phil. All right, so here we go. Reciprocal of 1/4 is 4 over 1, and I multiply by it. I multiply 8 by the same thing, 4 over 1. Great. Now when I do that, when I multiply a fraction, right, I don't do anything with the common denominator, blah, that's just for adding and subtracting. Here I multiply straight across the top, straight across the bottom, right? Let's do that. 4 times 1 is 4, and then 4 times 1 is also 4. So 4 over 4 is what I get here. And I'll write it the long way. You don't have to necessarily do this. 4 over 4x equals 8 times 4 over 1. I didn't do this part yet. 4 over 4 is 1. So it's just x equals this. But what do I have to do here? Right? Any integer, any whole number, can be written as a fraction simply by putting a 1 underneath it. Right? And now I have fractions. And just like I did here, straight across the top, straight across the bottom. Right? So what do I get? So x, the 4 over 4 canceled because it's 1. X equals, straight across the top, 8 times 4, 32. Over 1 times 1 is 1. But what is this really? Anything over 1 is itself. Right? It's exactly the same answer I just got. 32, right? 1/4 times 32 is 8, plus 2, it is 10. Great. So that's another way. So before I multiplied both sides by 4, this kind of also is multiplying by 4 on both sides. But if I had 3/4 here, I would multiply by 4 over 3. So I really just, this still is multiplying by 4 because 4 over 1 is 4. That's why this works. Okay, so again, I did the reciprocal thing, and I actually got the same answer, right? 32. Not too bad. There's yet another way to do this. Okay, so let's, what do I need to do here? Oh, I need just the stuff that's in black, right? Let's see if I can do this skillfully. I know I'm going through a lot of cases here, but these actually are the cases that you need to consider, or that you can consider. I'm going to redraw the 8. That you can consider, and then just find what the heck works for you, not for your math teacher. 8. So here, before I jump to solving for x, I'm going to rephrase this. I'm going to rewrite this to make something a little more clear. Right? Because here I divided because I had the opposite of multiplication being division. Here I can divide by 1/4 as I said, but that's a little, it's sort of an advanced move, but okay. But let's rewrite this. And let's do it in the following way. 1/4 is 1/4. Right? There's nothing, and actually 8 is still 8. But x, can I write x as a fraction? Absolutely, right? I just said anything, even if x turns out to be a fraction, anything over 1 is itself. So let's say that. So I say this, x over 1 equals 8. Okay, here we are with a fraction again. Straight across the top, straight across the bottom. Okay, okay, let's do it. I'm not trying to isolate x. I didn't do anything on the other side because I'm actually not changing the value of anything. I am simply rewriting this as this by just replacing x with x over 1. Anything over 1 is itself. So I did not change the value here. Watch what happens though. Straight across the top, 1 times x is x. Straight across the bottom, 4 times 1 is 4. And then again, I did not change the right side here. Equals 8. So this and this are absolutely equivalent. They are the same thing. This is a multiplication between the coefficient, that's what we call the thing out in front, the coefficient of x, and this is a division problem. But they're exactly the same thing. To me, to my eye, this appears a little what I would call cleaner, because now it's clear what the operation is that I should do, right? This is x divided by 4, right? So what's the opposite operation? It's multiplying by 4. All right, so I'm going to do that. I'm going to multiply by 4 on both sides. Right? And then what? The 4s are going to cancel. And then I'm going to get x equals 8 times 4, 32. Is that the third time we got 32? I think it is. And we got it 3 different ways. The key thing that I'm trying to get across here is that this, and, well, I can't very well draw it in a box over there, and x over 4 equals 8. They're equivalent. These are equivalent phrases. And the way mathematicians sort of denote that is by this, by the 3 horizontal bars. 3 bars. It's like an equal sign, but with 3 lines. This means that x over 4 equals 8 is the same thing as 1/4 times x equals 8. And I just demonstrated why that's the case. So there is yet another way. I'm going to erase this because this, I think, is, we've gotten that out of the way. Let's leave this here and talk about it. For anybody taking, did they talk about this in Algebra 2? Or maybe at some point in Algebra 1? I really don't feel like it's an Algebra 1 topic. Well, let's go back to 1/4 times x. Let's go back to that. 1/4 times x equals 8. There is one other way to do it. This is what I recommend. And sometimes I will choose this over this, depending on what the equation looks like. This one is pretty clean. Again, there's one operation to do and we're done. But I actually would, depending on the context, I would choose one over the other. Okay, so let's talk about one other thing. And since this is a multiplication problem, right? Something is multiplying x, so I'm supposed to divide by it in order to do that. And that's fine. I can do that. Let's show what that looks like and then discuss what actually happens. So 1/4, so I divide both sides by 1/4. I can do that. Right? This is fairly easy because anything over itself is still 1. And that's the idea, is that I want to get rid of the 1/4. So these still cancel. They still cancel out. And here's what, and I'm left with x. X equals. So x is isolated. Right? It's about to be some sort of thing. But whoa, what do you do with this guy right here? Right? For those who have seen it, it's not too bad. But for those who suggested they divide by 1/4 and get here and don't know how to deal with it, that's where people seem to seize up sometimes. And that's what I want to help everybody avoid. This is simple enough. But this is also possible. For those who have seen it and for those who are going to see it in their future, what we do here is when we divide, this is called a compound fraction because I have or is it complex fraction? No, I think it's a compound fraction. Am I getting it confused with a compound fracture? But which sometimes feels the same way. Is when we have a fraction with like a fraction over a fraction or something in the numerator and then a fraction in the denominator becomes weird, but there's a very simple rule, and that is the division here gets changed. We write the top, and then we write the bottom as a reciprocal. So the reciprocal of 1/4 is 4/1, and we change the division to multiplication. That's how we deal with a fraction over a fraction, or something over another thing that's a fraction. Again, you'll have plenty of practice on this if you haven't done this before. And then what do I do to solve this? Oof. Well, I use the trick of turning this into a fraction, right? So really I want to do this here. I want to put it over 1 because now I have a fraction times a fraction. And as we discussed, we go straight across the top, straight across the bottom, and we get x equals 8 times 4, 32, over 1 times 1, 1, which is, shocking, 32. All right, so that's 4 ways that I got 32 for this answer. But that's how we deal with this situation. You can divide by 1/4. But I feel like I'm detecting that that half the time when somebody says divide by 1/4, they don't know this situation here. They don't actually know how to do this yet. Or they're not good at it yet. And how do you get good at it? You practice. Right? The answer I give to every student, maybe they don't like to hear it, but it's actually true, and I'm not in the habit of, I don't know, it's not a lie, but I'm just honest with students. How do I get good at something? How do I get good at a particular technique? You start with 25 problems that exercise the technique, and you try to do 50 of them. That's the way to do it. I mean, these types of equations, I've done thousands of them by now. Yet sometimes I still screw up the basic calculations, but that's okay. That's being human, and that's pretty much all I am. I'm a human, and then I've also practiced. That's it. But again, I got 32. So you can do that. That's great. It's possible, right? So it's not for completeness sake. But this thing here, man, is so... I'm going to erase this because I really want to bring the spotlight on this guy right here. And this is gold. This is gold. This is the thing. This is the thing. This is really what I want to show. That is equivalent. All right, and it could be any. Actually, I'm going to erase all the other gibberish because we know that x is 32. Hopefully, you've been paying attention. All right, I'm even going to get rid of this. This is the thing. This is the gold here in this lesson. This is the snack. This is the tip or the tidbit. So if I have something that's a little bit more complicated, all right, well, we're going to erase my dollar green smiles and exclamation points here and see how many markers can I actually hold at one time here. Okay, so if I have x plus 2, x plus 2 over 7 equals 9. All right, man, there's a lot of stuff going on here. I can't subtract 2 like this 7 is in the way. There's a lot going on here. But this is fairly clear, right? That is this situation. Right away when I looked at it, I was like, boom, hey, man, I got to multiply by 4 on both sides. I really got to get rid of the denominator to get at the x. I can't do much. I can split the fraction apart, but that's one of those things that introduces errors. Sometimes you can't avoid it, but in this case, I think I'd try to avoid it. All right, so if I'm in this case here, I have something, and these guys travel together, man. There's invisible parentheses. Sometimes we explicitly draw them. I don't think we need to in this case. But here we are. All right, this x can be any gibberish up here. So certainly the first thing that I would think of is multiplying both sides by 7. Right? Okay. And when I do that, the 7s cancel. Right? And the denominator is gone, just like I did here. I multiply both sides by 4, boom, the 4 is out of there. Same thing. And what do I get? What's left? X plus 2. And 7 times 9, 63. Great. And now, simple one-step equation, right? X equals 61. Should have been in blue, but whatever. This is the important part. I multiply both sides by 7. That's this. But we can actually rephrase this to look like this and help us solve it that way. Sometimes it's a matter of like what you see first. And the purpose of homework and practice and just drilling this stuff over and over, is that you train what I call your intuition, and you train your eye for these sorts of things. You know, sometimes I see this as this, and sometimes I see it the other way, and sometimes I don't decide to rephrase it at all. But here, it may be worth rephrasing. So let's go back to the original statement. So we said that x is 61. Let's go back to the original equation. I'll erase all this stuff and just redraw the bits that I need. All right, so 7 is in the denominator. So I said when I have something over something, I could rephrase it as 1 over the denominator times whatever's in the numerator. Great, let's do exactly that. 1 over the denominator times whatever is in the numerator. And this is where I'm going to introduce my buddies. I said they were invisible a minute ago, but now here they are. You have to do this because 7 is dividing this entire quantity. And if I want to switch to the multiplication version with the 1/7 in front, I have to group them together. If I don't, I'll write this. Don't you write it because it's wrong. 1/7 x plus 2 equals 9. This is saying, remember our order of operations, sometimes called PEMDAS. This says multiply 1/7 times x, then add 2. This says add 2 to x first, and then multiply by 1/7. So try different values of x in here and show that this and this hardly ever give the same value for x. Right? We'll solve it and we'll see that that's the case. Okay. So all I did was use this idea right here. And this is now, I gave you the gold in a very simple case, and now we're stacking some other complicated stuff on top of it. But this is how it goes. Like, we have a very simple concept. Remember, I started the video with x equals 8. That was a very simple equation. I think it was 8. X equals 8. But now we stacked a bunch of things on here, and we're still doing awesome algebra and getting the right answers. This is the whole point of this discussion. Okay, great. Now, I have 1/7 times all this stuff. And we decided what? I'll pick one of the ways to do it. I could just multiply both sides by 7 to get rid of the denominator here, right? So, multiply by 7, multiply by 7. The 7s will cancel, and I get 1 times this thing, which is just this thing, right? So it's just x plus 2. And I'm going to take the parentheses away because there's nothing else here. X plus 2 equals 7 times 9, 63, right? And then what? Minus 2, minus 2 cancels, and I get x equals, right, because the 2's cancel, x equals 63 minus 61, same exact answer, right? Same exact answer. So, again, this is this sort of gold in action, right? This is exactly the same thing. I'm trying to think of something that's totally weird that I could still use this idea, but maybe this is not, the point is not to get weird about it. The point is to maybe try out a few things. Next time you see something like this, where you see some sort of fraction, and see what you can do. There are multiple ways to attack this very problem, but I wanted to take this problem and translate between this version of the problem and this version of the problem and show that we get exactly the same answer. Now, if I really, really, really wanted to generalize, let's do that. And then we'll be done. That's the end of this little tutorial, is to just deliver this information. So I want to say something like, this. And you see that, so for people who are maybe in Algebra 2 or something, we could say something like x over anything, and I'll call anything little a, equals some other thing. Right? X over a equals b. I don't know what it is. This is the same as 1 over a times x equals b. X divided by something equals b is the same thing as 1 over something times x equals b. And then I'll write the way that you solve both equations. Right here, I multiply. Well, I'm going to write it again and then do it. Okay, so this is the gold. This is it. This is the thing. X over a equals b. Let's solve that. I said that a is a number, and always remember, I think in any math you're going to do, that anytime I have letters, they always are stand-ins for numbers that we don't know, or they're also stand-ins for any number. Keep that in mind. Another thing that math teachers don't talk about. This one we said it's a division problem, right? X divided by some number equals some other number. So we multiply by a, right? And the a's cancel, and I get x equals b times a. Right? Now let's look at this guy. I'm going to write it again. 1 over a times x equals b. Here we said we multiply both sides by the reciprocal of this guy. And what's the reciprocal of any fraction? You just turn the fraction over, turn it on its head. All right, so now we are going to multiply by the reciprocal. This is a over 1, and this is times a over 1 to both sides. All right, and we'll point it out just so we remember. When we multiply a fraction, we go straight across the top, straight across the bottom. This guy, I'm going to write as a fraction. Remember, b, anything over 1 is itself. It's convenient to turn it into a fraction. Right? Just in keeping with that. And again, straight across the top, straight across the bottom. Okay, so what do we get? A times 1 over a. A times 1 is a, and 1 times a is a. A over a, anything over itself is 1. So this goes away. And we have 1x, and 1x is the same thing as x. And this is b times a in the top, which we write b times a, over 1 times 1, which is 1. Anything over 1 is itself. X equals b times a. And that's what we talk about in terms of like making some sort of rule. And there's further generalizations. If you're in Algebra 2, you probably have seen function notation. So I could put f of x over f of something, blah, blah. I could do anything like that, or over g of something, blah, blah, blah. I could do tons of things. But this is the goal. It's the basics. Something divided by something is the same as 1 over the thing we're dividing by times the numerator. And depending on the problem, as we saw, you can rephrase and actually get the same answer. And with a minimum of ways to introduce errors, which nobody wants to do. All right, so that's pretty much it. I said it would be quick, but I have a feeling it's a little longer than I expected, but that's okay. I think it's worth it. I feel like there were a few examples that we talked about that are useful, and then I just give you this guy right here. And if you're a parent who's working with your kid on this sort of thing, remember the triple bars means is equivalent to or is the same thing as. Usually I say that. This is the same thing as this. This is not an equation. I don't solve. An equation has an equal sign. This is not an equal sign. Yeah, so that's it. But this is the thing. Try it out. See if it works. See if it helps. Remember some of the subtleties of using parentheses like we did in one of the other problems? But that basically is it. I've been wanting to talk about this one for a while because, again, I feel like it's one of those things that sometimes becomes obvious, but sometimes not. And it becomes a little bit of a struggle sometimes about concerning how we deal with these sorts of mathematical phrases and how we get around them to isolate our variable. All right, I just want to thank you for joining. Hopefully you learned something. If you have questions or if there's anything I can state more clearly, leave a comment and let me know. Hit the like, subscribe, hit the bell notification. Honestly, I'm not sure what that does, but try it out. Everybody else seems to say that, so I'll say it too. And remember, like, if your math teacher is terrible, I can help. And actually, why don't you talk this over with your terrible math teacher and your good math teacher? All right, thanks for joining. I hope to see you guys again. Thanks very much.